In this video I will solve question number 1.122 from Problems in General Physics by IRODOV. First, let's look at the problem. First of all, I would like to tell you that to solve question number 1.122, it is necessary to solve question number 1.121 because I will use some result of this question in the current question. You will get the link to this solution in the description below, and I will now continue with the current question. It says that a disk of mass m slides with the zero initial velocity down an inclined plane set at an angle alpha to the horizontal. Having traversed the distance l along the horizontal plane, the disk stops. So the initial velocity is 0 here and the final velocity is again 0. So the change in kinetic energy is 0 in this question. This is a key point in this question. Find the work performed by the friction forces over the whole distance, assuming the friction coefficient k for the both inclined and horizontal planes. Another key point in this question is that IRODOV sir didn't give us the height at which the disk was initially kept. So we will have to find that out. So I will show you how to solve this question. So this is the diagram. So initially let us assume initially at height 8 the disk m was kept, and according to the question, after moving for length l along the horizontal plane, it stops here. So force working on the disk is normal force, the gravitational force, and the component of gravitational force along the inclined plane is making it to move. And so for solving this question, we will have to use the work energy theorem, and work done by conservative force plus work done by non-conservative force. Conservative force is gravitational force here, and non-conservative force is frictional force here, is equals to change in kinetic energy. As I have already mentioned, change in kinetic energy is 0 in this question. So we can directly equate work done by non-conservative force, that is frictional force, that is what we need in this question, minus of work done by gravitational force. So work done by gravitational force will be mg(h), and clever IRODOV didn't give us this height h, so we will have to find some way to calculate h. So let us divide the work done by frictional force in two parts. For this part, till this point, let it be W1, and for this part, let it be W2. W2 will be simply just this is the frictional work done by frictional force is n times k. N is the normal force, and normal force is mg in this case. So frictional force is k, and work done will be force times length l, as both are in the same direction. So we can separate, frictional force equals, one part is mgkl, and from the results of the previous question, when the force acting on some particle or some system of particle is tangential to the trajectory, and it is, in this case, it is tangential to the trajectory. The trajectory is this inclined plane. The work done is simply work done by frictional force is simply equal to mgk. K is the coefficient of friction times the horizontal length u. In the previous question it was l, if you remember, and you will get the link to the previous question in the description below. You must follow that video for solving this question. So it will be equal to mgku plus mgku, and we can, so from this triangle, so this is alpha, it is given in the question. H by u is tan alpha, so h so u will be, we need u, h by tan alpha. So we will substitute mgkl plus mgk is by 10 alpha, and work done frictional force from this equation is minus of mgh. So we can solve these equations for h. We will get that. So expression for h in terms of the known quantities is this one. So now it becomes pretty much simple. The work done by frictional force will become minus of mgh is from here kl 1 minus k cos alpha. This is the expression, final expression for work done by frictional force. Thank you for watching. Follow my channel for more solution to problems in general physics. Thank you.